All right, guys, it is Make a Mistake Wednesday. Our notebook should be out. I'm going to show you a mistake on a problem I did. Just to review, I want you to discover the mistake, find it, and then I want you to try to do the problem the correct way in your notebook. All right. Here we go. Rewrite with integer coefficients. 1/4 x minus 2 equals 2/3. I've also added a word bank. And what I would like is when I call on you and I ask you to explain your thinking, use as many of the words in the word bank as possible. Okay? All right? And I will give you a little theme music, possibly a little hint as to what we're doing today. At the very least, we should have the initial problem written down. The word bank should also maybe give you a hint about what's going on here. Okay, well, what did I do first?
Okay. With problems like this, we would use distributive property.
Not yet. What did I want?
Found a common denominator.
And then what do I do with it?
You then use distributive property on it.
Get in there. It's a great question. Is 1/2 an integer?
Oh no.
No.
It's numbers.
What kind of numbers?
Like 13 and like 5.
All right. All right, Danny, can you read what the thing says at least? What am I doing here? Which brings up a couple questions. What is an integer? A whole number. We agree with that?
Mm-hmm.
Yeah, big thumbs up if you agree with that. You're very close. There's something different between integers and whole numbers. There's a slight difference. Elizabeth? Integers are negatives.
Oh, right.
So, and negative numbers are integers, right? Whole numbers are just, like 1, 2, 3. Think of whole numbers as like numbers you can count cows by, right? If you can't have half of a cow. right? At that point, you have steak. You know what I'm saying? All right. And what's coefficient?
Coefficient is it's like, I don't know how to explain it, but I know it's
What's the coefficient in this problem?
the coefficient
Would be 1/4, right? Hannah, what is a coefficient?
the number that is multiplying with.
Yeah, the number you're multiplying x by. Now, when it says rewrite with integer coefficients, you're going to see this on your test. What that means is not only the actual coefficient, but the whole problem should be integers, right? So the 2/3 would also, I would want an integer with that, okay? Sienna, what did I do? Can you read what this number is? Before I cross it out. It is 12. Now what am I doing with 12? Before I cross it out though, what operation am I doing? Am I adding 12 to both sides? Am I subtracting? Am I dividing? Am I multiplying? Not quite. Ryan, what am I doing with 12?
I think you were trying to divide it by 1.
Well, I did put it over 1, so technically that is dividing by 1. Emily? I'm multiplying what by 12? Well, where are the parentheses? When we're using fraction busters, right? What's my first step? Yosh? No, that comes after. How did I get 12? Why 12? Danny?
You made a common denominator.
I found a common denominator, right? What are my two denominators in the original problem? 4 and 3. And a common denominator, in fact, the lowest common denominator is 12, right? Now, when we're using fraction busters, what do we do with that common denominator? Bella?
Do we cross simplify?
Eventually, but before we can cross simplify, what operation are we doing?
Distributive?
Not quite. Okay? We're multiplying both sides by the common denominator, right? And what that will allow us to do is to cross simplify. So by cross simplifying, we can get rid of the denominators and we don't have fractions anymore. Okay? So if we do this, we're going to multiply both sides by 12 or 12 over 1 since we're already dealing with fractions. And now I can cross simplify, but did I do that correctly? Can anybody find a mistake? Hannah?
So you just distribute the property for 1/4, but you didn't do it for -2 when you're doing the distributive property.
Good. Do you guys see that? I did not distribute. This is probably the most common mistake in all of math, and particularly when we're rewriting with integer coefficients. If this was a fraction, we wouldn't have forgotten about it. But I forgot about it. And if you remember when we did the original fraction busters, I had you write out what I want you guys to write out now. 12 over 1 times 1/4 x minus 12 times 2 equals 2/3 times 12 over 1. I'm showing that I've distributed the 12 to both of these. Does that make sense? So now everybody has this down. I want you guys to cross simplify and then rewrite it with integer coefficients. Jocelyn,
Yeah.
what does this whole thing become?
That would become 3x minus 24 equals.
Oh, okay. How do I get 3x? What did you simplify?
I cross simplify 4 by
Became 1. And 12 became?
3.
Good. And this becomes?
3x.
3x, right? Don't forget about the x. Okay, we're not simplifying the x. And then minus what?
Minus 24.
Yosh, what does that equal?
That equals,
How do I cross simplify this?
change
Good. Now what? So what's missing? What's different about the mistake I made in this? No, I cross simplified. I forgot the negative 2. I left that alone, right? We have to use what property, Yosh? The distributive property. Helps out that it's written right here. Right? Okay. So don't forget that. When we're multiplying or we're using fraction busters, we find a common denominator. We then multiply both sides of the equation by the common denominator, but we have to multiply each term by the common denominator. We can't forget about one of the terms. All right? Questions? Okay.
When we do this, do we simplify even further, like where x equals something?
Well, eventually, yeah, we would solve for this, right? But would you rather solve 3x minus 24 equals 8 or 1/4 x minus 2 equals 2/3? This is a lot easier, right? We know what to do now. Yeah? So if there's fractions, right, the first thing I would do is get rid of the fractions by multiplying by a common denominator. And then we would, if I'm using a common denominator, these will always be able to simplify to 1, right? Just by the definition of common denominator. And then I can get it here, and now I can just solve. Right? But don't forget, just because this isn't a fraction, we still have to multiply it. Because you have to do everything equally, right? Or else you're cheating. Mr. Hippie comes in here and starts banging yardstick. Good? Okay. All right, don't worry about the warm-up on the slide. But there's your homework. The lesson today is finding missing information in proportional relationships. You have a practice test that you'll get on the way out. Test is next week. I know we only have one more lesson in this chapter. Not that?
Do we have a common week?
No.
Okay.
It's the same,
Yeah.
All right. Volunteer to read. Danny.
Throughout this course, you have made connections between different representations of proportional relationships. In this lesson, all of these ideas will come together to uncover a new strategy for finding missing quantities in proportional relationships.
Beautiful. Thank you. All right. Pencils down. Expo markers down. Now, it's going to upset you, but I don't want you to actually solve this. Way back in chapter 4, we talked about Casey, and she was trying to find out how many pounds of Havarti cheese she could buy for $10, knowing that 3 pounds cost $7.50. She wrote the equivalent ratios below. Work with your team to brainstorm a list of all the methods that you can think of that Casey could use to find the information that she is missing. I just want you talking about things we can do. Right? Can we divide by a number? Can we multiply by a number? Can we add something? Can we, I don't know, flip it all around? Who knows? But I want to go over the expectations of when we're talking in groups. Okay? So I would like you guys to actually physically face each other. Not just turn your necks, but physically face each other, as demonstrated here by Yosh and Parsa. If you're in a group of 3, Justin, will you scoot back just a little bit? Bella and Sammy can now face, and everybody is facing each other. Okay, at the circular tables, you guys have it pretty easy. You guys can just either pair off or work as a team. It's up to you. All right? Please be talking about the question, not Fortnite. Okay? And even if you have no idea, just try something totally random. Try adding y, I don't know. Just try something. Because when I call on you, I want you to share with me what you tried. All right? It doesn't have to be right. It just has to be something. Okay? So I'm going to give you guys a minute and a half. Just discuss what you can do in order to find the missing piece of information. Go. What do we think? Anybody got any ideas?
I said something.
What'd you say?
Find the unit rate and just experiment.
How would you find the unit rate?
I would divide the pounds by 3 and the cost by
We came up with 2 so far.
Ooh. Can't wait to hear about it. Hey, pencil down. What are you doing? Quit cheating. Pencil down. Pencil down. No. Quit trying to do extra work. Bella, what'd you guys discuss?
Well, it's kind of hard to explain. I don't know this. Divide maybe.
Divide what?
So divide 7 divided by or $7.50 by 3, because then you could get the amount it is for 1 pound.
Joe.
And then you can multiply that by 10 and then get the answer. But I was kind of thinking, well, it's in fractions, so probably not.
Okay, I like that. Elizabeth.
So we thought 2 ways you could do the 5D process.
Okay, that's true.
You could also do a number line.
A number line. How would we do a number line?
Because like you could have
Keep going. Keep going.
and then what is
Goldman. Hey. Oh. All right, don't worry about it. I don't know why I thought he had. I knew he didn't have you. Yeah. Thank you. Sorry about that. So, number line.
So like you could have like the amount of like pounds on the top.
Oh, I see. It's like a dual number line.
Yeah.
Got it. Yes, absolutely. Good. Anybody else got anything differently? Danny? How would you find the unit rate? I wouldn't divide $10 by $7.50. Emily? Yeah, what would that tell me? How much 1 pound costs, right? Yeah, good. What happens if I divide 3 by 750? What would that tell me?
The unit rate of how many pounds you can get for $1.
Yes. That would tell me how many pounds I can get for $1, which isn't the unit rate we would normally associate with buying cheese. But that could also help us. Good. So there's a lot of ways to do this. Yes? Anybody come up with anything else? Good. Let's continue to explore. Graham knows that he earns $4.23 every half hour. He wanted to know how much money he would earn after 1 full week of work, which is 40 hours. He wrote the equivalent ratios below and quickly sees a way to find his answer. What do you think Graham is thinking of doing? Solve Graham's equation. Solve this however you would like. Be prepared to explain your thinking. Okay? Good luck. You can work with your partner.
What did I miss?
Solve for x. We guys, I want you guys working together. So talk through it. Talk through it.
When she, anytime I look at her, she just laughs.
No, okay, I was laughing.
And now she got Sammy to do
You were
it.
over there, like smiling, going so funny. You were like, he got sad after a second.
No, but she does it
Put
all the
it up
time.
against her.
I don't have like just plain white paper, like a piece of just.
And, what do you think?
What we're doing is we're multiplying 1/2 and 23 cents by over half by 20 and the amount that
Keep
we're
going. Keep exploring with that.
Oh, I got it.
Oh.
We are kind of doing it together in a way.
Okay. In a
We
way.
had the same.
In a way.
Had
In a
the
way.
same idea.
What does that equal?
1 hour.
Okay. So now
And
what
we were
can
doing
do?
it times 40 to get 40 hours.
Good. Show me that. But we gotta start. So write down the original thing. When I write it down, make sure you're paying attention to how I'm writing it, right? So it's nice and clear.
Hold on. Goldman? Wait. Goldman.
Let's see how many of these we can get. Anybody got a volunteer for Yosh? How'd you do it?
I added $4.23. Yeah. So 4.23. And then I got $8.46.
What does this equal?
1 hour.
Okay, so this is like half hour equals
That's a full hour.
1 hour. Okay.
And then I multiplied $8.46. 40. And got. Wait, I just did that.
No. Well, so you're saying it's 846. So instead of what he has is 423 over 1/2, it's 846 over what?
Over 40.
Now, how many hours is this?
1.
1, right? So this is my ratio. And what are you going to multiply by?
40.
Just 40?
40 over 1.
Well, what do I want to get? How many hours do I want to get?
40 hours.
40. So what am I going to multiply this by?
40.
All right, 1 hour times 40 is 40 hours. What's 846 times 40? Did you do it?
No, I did 40.
Okay.
$40.
Good. Thank you for answering in a dollar amount. Yosh, what did you multiply by?
I multiplied by 40.
Not by 40.
By
What did you multiply by? What is this? What does this look like? What whole number? You're stuck in an academic vocabulary rut. What is this? 40 over 40. What does that look like? It's pretty big. Joe? Joe? Giant one.
big one.
All right. So Yosh, you're using the giant one method. Right? Make sense? Bella, you got a different way to do it?
Kind of the same with you. So this, I didn't do the fractions. I did the same thing with David before, $4.23 plus $4.23.
Okay. But you just didn't set it up like this?
Yeah, I didn't
Okay.
set it up like this, but if I'm like, could you do this like on a test and like still get credit? Like, so after I did that, I did 8 to $8.46 times 40, and I got 300.
This explains why.
Oh, okay.
Right? So it's very important when we're doing these ratios and stuff to write it down like this to explain. This is your explanation. If you just did the 8, this, and then multiplied it by 40, you would have to have a couple sentences explaining why you did that. Right? Arwen? What?
Since we doubled the half hour, we can just double the 40 hours.
Yeah. In fact, I can amend Yoshi's this adding. I can amend this to what giant 1? How do I go from 423 over a half to 846 over 1?
Multiply it
By 2 over 2. Thank you for the group effort. Right? So you're both using giant 1s, right? And what do we notice about the giant 1s?
you can just multiply. Yeah, I guess.
You guess what?
You can just multiply. I guess.
Yeah. What's 1 times 1? 1. Well, what's 2 over 2 times 40 over 40? You basically took he took 2 giant 1 steps, right? And you simplified it down to 1. Make sense? Okay. So giant 1 is very useful in solving for these missing parts if we can use it. Right? In this case, 1 half hour goes into 40 hours evenly. So it made it pretty easy. Okay? The thing I like about fraction busters is it always works. So let's try fraction busters with this problem. So what's the first thing we have to do in order to use fraction busters?
Turn them into fractions.
Well, they already are fractions, right? I got 4.23 over 1 half. I'm just going to leave out the units for a second. And x over 40. What do I have to find when I use fraction busters? Gabe? Common denominator. I want you to find an elbow buddy and whisper to them what you think the common denominator between 1 half and 40 is. It's a common denominator.
All good. We all good here.
All good?
All good.
All good? You guys, common denominator?
What?
What's a common denominator?
I don't know either.
All right. Josh, what do you think? What's the common denominator between 1 half and 40? Not quite.
Me.
Now, hands down. Remember, eventually we're going to multiply by the common denominator, right? And I want to be able to cross simplify 40 in the common denominator. Right? So what's a number? I can't simplify. If I put 20 up here, it'll simplify to 1 half, and I'll still have a denominator. I want no denominator. Bella?
You can do 40 as the common denominator.
Does 1 half go into 40?
Yes.
Sure does. Okay. So if you have not already done this, this is very important. This is kind of an ugly problem. I have a fraction in my denominator. I want you to write the original problem, and then I want you to multiply both sides by 40, cross-simplify, and write a new equation with integers. Okay? Good luck. And hopefully for Graham, the price is right. right underneath. Just everything in brown. Actually, that's right. Emma, let's simplify this. We'll do the easy side first. What does this side simplify to? How can I cross simplify? And they just kind of go away, right? It's like a crooked giant 1. What does this side equal now?
X.
Perfect.
Just X.
Just x. Sorry, I jumped the gun a little bit, right? Because it's x times 1 divided by 1, right? So it's just all x. Okay. That was the nice side. Now we have this ugly thing. Addie?
Hey, that's not nice to say.
Addie, what do you think?
I think the interior got like 84.6.
84.6. How do we cross simplify?
I cross-simplified the half and the 40, and then the half would be 1, and then 40 would be 20.
40 would be 20. Why 20?
Because half of 40 is 20.
True. But remember, we're not, what does of mean? Multiply. Am I multiplying 40 times 1/2?
Yeah.
I'm dividing. Right? Because I have a numerator and a denominator. Right? Just like this. I'm not multiplying 40 times 40, right? I'm dividing. 40 divided by 40 becomes 1, which is why we can get rid of it. So what's 40 divided by 1/2? If I have $40, how many 1/2, how many 50-cent pieces are there? 80. So that's pretty tricky. Okay? Especially with the fraction in the denominator. But now, Yosh, question?
If you did 40 over 1 times 1 over 2, would you just multiply 40 by 2? And then
If I divided it by 1/2, you're right. It would become like a multiplication problem, right? Because I multiply by the reciprocal. The reciprocal is 2, so I do multiply 40 times 2. Okay. Elizabeth, what does this become?
And then you would just multiply 80 and 4.23.
Good, which we did right here, right? So do you guys see how that becomes the same problem? The difference between this method and this method is I need this number to be nice and easy to multiply across, to have a giant 1, right? If this was 37 minutes, right, and I wanted to know what 40 hours, or if it was like 3.5 hours, and I wanted to know what 40 hours is, I don't have a nice, easy giant 1 that I can multiply across. Okay, but if I do this method, I can always calculate it. All right? Real quick, I want to do A. So set this up. You can solve it however you would like. I want to see if we can solve it 2 ways. So I'll put 1.5 minutes. Good luck.
For this, for the common denominator, I'm doing 15. Just to make sure this is equal to 3x, I just release the x out.
But show me the work. Show me the work. All right, volunteer. Joe.
It's divided 2/15 by 3.
Not, well, kind of by 3, but not. Did you divide 15 by 3?
Yeah.
To get 5, right? So 15 divided by 3 is 5. So what did you do to 2?
Divided it by 3.
Divided it by 3. What's 2 divided by 3?
0.6 repeated.
Or just 2 divided by 3, right?
Yeah.
Which equals 0.6 repeating. So this is kind of like a reverse giant 1.
Yeah.
Right? Nice find. Nice find. Good job. All right. Anybody else do a different way? Danny? Let's see what'd you do first.
I made 15 colors.
Good. So what do we do with 15?
I made some 15 in one of those ones.
Okay. I've said this a lot. It's very important to be writing this as I'm writing it. Okay? It's going to help us eliminate mistakes. Okay. Go ahead, Danny.
Then on the right side, I just got both.
On the left side?
Yeah.
And what am I left with?
2.
2 equals?
2 equals, I crossed out, I made 5 on 1, and I made 15 on 3, and I got 3 on.
Anybody not quite sure how we got 3x over here? It's the same as 15 divided by 5, which is just 3. Good. Go ahead, Danny, finish it.
You divide 3x.
What,
Well, you divide 2. Wait,
what do I divide by?
you divide 3.
Why 3? Beautiful. 3 is the coefficient, so I divide both sides by 3. What do I get on the left side, Danny?
You got
0.6 repeating, or 2/3, right? Equals what? Equals x. Bella.
I have a question.
Yes.
Every time,
Oh.
so every time, like, say 2 can't be divided by 3, or 3 can't be divided by 2, you just make it a fraction?
Yeah, you can leave it as a fraction. Okay. Good job.